Right, hello everyone. Another session. Today we discuss module 11 IPv4 addressing. Module objective. The module objective is to calculate an IPv4 subnetting scheme to efficiently segment your network. Let me change this first. Right. So we're going to describe the structure of an IPv4 address, including the network portion, host portion, and mask. Compare the characteristics and uses of the unicast, broadcast, multicast addresses. Explain public, private, reserved. Explain how subnetting segments a network to enable better communication and calculate the IPv4 subnet. All right, this is module number 11. And I think it's fair to probably begin by defining what an IPv4 address is before we get to the subnetting part, the addressing part. What is an address? I think in the previous sessions, in the previous modules, we got to discuss every device needing a unique identifier so that you can identify a device in a network. It probably started with when we did the basic configurations, we changed the host name. That is an identifier of a device in a network. In your network, right? When we talk of the IP address, we are talking of an identifier of a device over the internet. That is the internet protocol, by the way, IP, internet protocol. So over the internet, how is your device identified? It is identified by its IP address. That is layer 3. At layer 2, we also learned about the MAC address. Your device can also be identified by the MAC address at layer 2. In this module, we'll focus on layer 3, the version 4 of the IP address. And we'll look at how do you address your devices. There should be a procedure of how you should assign your addresses. And that is what we'll be looking at in this module. The structure. An IP address is a 32-bit hierarchical address that is made up of the network portion and the host portion. When determining the network portion, you must look at the 32-bit stream. A subnet mask is used to determine the host portion and the network portion. To identify the network and the host portion, the subnet mask is compared to the IPv4 address. The actual process is used to identify the network and the host portion is called ending. All right, these slides, they probably put a lot of wording on very simple stuff. An IPv4 address is a 32-bit number. Let's start there. 32 bits, binary, ones and zeros. 32 bits, and the 32 bits are divided into 4, let me say, portions, into 4 groups. So you can see this is a 32-bit number right here. It's divided into 1, 2, 3, and lastly, this is the 4th one. And of those 4 groups, there are 8 bits in each of those 4 groups. And the 8 bits represents a number which is decimal so that we can be able to read what the IP address is. Going back a little bit, computers, network devices, the language they understand is this one right here. This language that is right here is for us so that we can be able to read those numbers. Of course, we can read binary, but it's not everyone that understands binary. There are some people who understand the decimal way better than the binary. So these numbers at the top, the 192s, they are for us so that we understand. It's much easier to read those. The ones and zeros, they are for the computers. So representation of the version 4 of the IP address, it starts with the binary, those 4 groups, each group has 8. Then those 8 bits represent one decimal number. Then you have what we call an IP address. So if I look at these numbers, let's look at this example that we have. So I have 1, 1. I'm looking at this one. 1, 1, 1, 2, 3, 4, 5, 6. That's the binary. Those are the first 8 numbers. If you did your module 5, I think titled numbers, there was emphasis on conversion of how do you convert a number from binary to decimal, or vice versa, as well as how do you convert a number from binary to hexadecimal. I think that is what chapter module number 5 is all about. Conversion of binary to decimal and binary to hexadecimal. So in this case, we want to have a conversion of binary to decimal. How do you do that? If you have your own way, okay, this is my way. It makes easier for understanding and explaining the things that follow. Converting this one, I always say the first number represents 128, the second one represents 64, 32, 16 divided by 2, 8 divided by 2, 4 divided by 2, 1. So if I have 1, 1, I have 1 here, 0, 0, 0, 0, 0, 0. Where there is a 1, it means I have 128 plus, where there is a 1, I have 64. Where there are zeros, I have 0 plus 0 plus 0 plus 0 plus 0. 128 plus 128 plus 64, that gives you a sum of 192, and that gives you this number right here. This should be the foundation of your understanding of IP addresses. Conversion of the binary to hexadecimal. And the easiest way to do that, understand of the 8 bits that you have, you start with these numbers: 128, 64 divided by 2, 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 divided by 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. If I have all bits as 1, 1, 1, 1, and I add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, I probably get 255. That's why for this binary number 11111, I have 255. So to summarize what I've just did here, an IP address is a 32-bit number, binary number. So we have 32 bits. Those 32 bits are divided into 4 groups of 8 each. So 8 bits, 8 bits, 8 bits, 8 bits. And those 8 bits represent one decimal number. It means an IP address, it has 4 decimal numbers. 1, 2, 3, 4. That's the starting point. Once you now have those numbers, you can then go and define what is the network portion and what is the host portion. So the IP address, it has 2 portions, the network and the host. If we have a router, if we have a LAN, this is LAN A, this is LAN B. You see probably this is 192.168.10.0. You see a representation like this, 192.168.11.0. Right. It has what we call the network address. It's sort of the neighborhood. It's sort of, if we say, I live in Harare, it's the same way as saying, I am in this network. You have not given your specific address, but you just said, I live in Harare. That's the network address. If you then say, I live in Harare, Highfield, house number 822, it means you have given the host address. It's now more specific. So the network gives you where the host is located. That's the network the host is. That is the network address. Then the host portion, it gives you a more specific position where the host is. We'll get there. So how do you separate those two things? The network ID, the network portion and the host portion are separated by what we call the subnet mask. The subnet mask is also a 32-bit number where if there are ones, we say it matches. If there are zeros, we say there are no matches. If the subnet mask has ones, it means that's where the network portion is. If it has zeros, no matches, it means that's where the host is. So if I'm looking at this IP address that is given here, 192.168.10.10, and the subnet mask, I have 255, 255, 255, and 0. It means where all there are ones, continuous stream of ones, that is my network portion. That is why we have this as my network portion. So an IP address, it has two things, the IP address itself and the subnet mask. So you see the IP address that I have there. I can write it like this: 192.168.10.255.255.255.0. An IP address is represented by these two numbers. If you can remember when we did the configuration of the interface, the command was IP address, then there was the IP address and the subnet mask. The reason why they go as a pair, it's so that you can identify what is the network portion, what is the area where the address is, and what is the host portion, what is the specific address of where the device is. So these two numbers, this is how they work. So this becomes your network side, and this becomes your host portion. Let's continue. We'll probably get there. Let's not get stuck there. The prefix length. A prefix length is a less keep some way to identify the mask. The prefix length is the number of bits set to 1 in the subnet mask. The prefix length, instead of having 255.255.255.0, as in the previous example, that is the subnet mask in the previous example. 255, 255, 255. That was the subnet mask in the previous example. What it means, I have all ones here, 8 ones, I have 8 ones, I have 8 ones here. The prefix length is a sum of all those ones. So I have 8, I have 8, I have 8. The sum is 24. So for this subnet mask, instead of writing this, I can represent my IP address as 192.168.10.10. I'm using the previous example, /24. This is a representation of, it's now different notations of the same thing. This is correct. This is correct as well. It's the same thing. So this representation, it has the subnet mask. And this representation, it has the prefix length. So the prefix length, it is a number which shows you how many bits are used for the network portion. And if you go to the examples, the subnet mask is 255.000. It means there are only 8 bits which are being used for the network portion. Therefore, the prefix length is /8. If I go and look at, this is the example that we had, 255, 255, 255. Those are 24 bits. Prefix length, 24. If I have 255, 255, 255, 128, what does that mean? You can see there are 24 here to represent these 255, 255, 255. Those are the 24. But there's an extra one here, 128, representing this one. That extra one, it gives you a total of 25. So, a representation of the IP address, two things. I can have a representation with the subnet mask, which is a bit complex, not complex, but at this stage, it can be complex because we have many numbers. Or you can have the prefix length, which is just one number, representing the number of ones that you have on your subnet mask. We'll get to more examples. We'll probably get to understand what exactly we are doing. All right. Determining the network. Determining the network. Let's forget what is on the screen. These slides tend to have a lot of wording, but it becomes very difficult to explain what is written there. All right. Determining the network. How do I determine the network address? Let me put it this way. I have this address. This is the IP address of my device. This one right here. 10.10.10. And the subnet mask is 255.255.255.0. That is the IP address, let's say, of PC1. That is a unique identifier of PC1 over the internet. If I want to communicate with PC1, I send whatever I'm sending to this address because it leads me to PC1. How do I determine the network? To determine the network, you use the subnet mask. Where there are all ones, it means that portion remains the same. Where there are all zeros, that portion becomes zeros. So if I'm looking at 192.168.255, this is 255.255.255.0. This portion, it has all ones. This portion, all ones. Therefore, this remains the same. This portion, all ones, this remains the same. This portion, all ones, this remains the same. This portion, it has zeros. Therefore, this 10 changes to a 0. And this gives you a network of 192.168.10.0. And that is what you have right here. Simplified explanation. The explanation with AND, why I'm not using that explanation, for guys who don't have a very good background in those logic values, it might be difficult for you to understand why we are ending. What AND means, if there is a 1 and a 1, it gives you a 1. If there is a 1 and a 0, it gives you a 0. So it's sort of multiplying 1 times 1, 1, 1 times 0, 0. So with 192.168.10.10 in binary, this is my 192.168.10.10 in binary. And this is my subnet mask in binary. If I end the values, the respective values from my address and my mask, this is what I get. So you can see 1 here times 1 here. It gives you a 1. 1 here and 1 here. It gives you a 1. 0 here and anything here. It gives you a 0. 0 here. It gives you a 0. We have all zeros here. 0 times anything. It gives me a 0. That's why we have zeros there. You do the same up to get to this point. And in binary, you get this after ending. And after ending, what you get is the network address. So in summary, if this is my address, this address is saying I live at 822 Highfield. I'm in bedroom number, I don't know, bedroom number 1. It is giving me the specific position of the device. However, if I say my network is 192.168.10.0, I'm saying I live in Harare. Basically, I'm not giving the specific of my address. So those two things are very important. Saying I live in Harare, it's important. It gives the sender an idea of where you live. So if I want to send, it means I need to send to someone in Harare. I don't send in Bloy. I need to send to someone in Harare. The network address is very important. The host address is important. because it gives you the exact position of the device you are sending. Two different addresses that we have there. The host address and the network address. And how do you distinguish between the two? The subnet mask. The subnet mask is used to distinguish between those two. Right. Video. We don't have a video. Let's go here. Network host broadcast addresses. We have types of addresses that we have. We have what we call the network address. We've touched on that. If we had 192.168.10.10, that is my network, that is my host address. If my mask is /24, that means we have 255, 255, 255, 255. 0, I mean. Here we have 0. That is my subnet mask. A combination of my host address and my subnet mask, it gives you my network. This is my network, 10.0. So this is my host address, and this is my network address. Then we can add what we call the broadcast address. What is the broadcast address? The broadcast address is an address which is used to send to devices in the network, to all the devices in a given network. I said the network address is very important. Saying I'm sending to people in Harare, to someone in Harare, is very important. Why? It allows you to say, I want to send to everyone in Harare. And that is what we call a broadcast address. So the broadcast address, we can easily get it from the network address. If I say I'm sending to someone in Harare, it also gives me a chance to say, I want to send it to everyone in Harare. And that is what we call a broadcast address. And how do we determine that? Let me see if we are there yet. The broadcast address. Let's look at this example and see if we are there yet. From the diagram, I can see I have a host, and this is its host address. I have another host address, .55, another host address, .101, another host address, .12. The network address is .0. The interface here is .1. The broadcast address. Let's get into it. What is the broadcast address? Provided I know what the network is. The network is 192.168.10.0/24. It means the network address and its subnet mask is like this, 255.255.0. That is my network ID. If I want to send to every device in the network, it means the host portion becomes all ones. The bits in the host portion becomes all ones. Right. Let me look at this address. This is my network address, 192.168.10.0. And this is my ID in decimal, and this is my ID in binary. This is my first 8 bits, second 8 bits, third 8 bits, and lastly, my fourth group of 8 bits. Because I have a 255, 255, 255, it means these first 3, these are my network portion. And it means these are my host portion. When I say I want to send a broadcast, the host portion becomes all ones. So if this side becomes all ones, 1, 2, 3, 4, 5, 6, 7, 8, what will be that decimal number? Is equal to 255. So if I want to send a broadcast, my network address will become 192.168.10.255. 255. And that is what we call a broadcast address. Very important thing to grasp here. If I want to send to this PC, I use 192.168.10.10. If I want to send to this PC, I use .55. You can see by the color, I think there's a blue. If I want to send to this one, I can use .101. If I want to send to this one, I can use .12. If I want to send to all of them, to all of these devices at once, I use what we call the broadcast address. And I use 192.168.10.255. You don't say if I want to send to all the devices. I say I send to this first, then I send to this again, then I send to this. I have 4 transmissions there. No, you don't do that. You send to one address, which is what we call the broadcast address. If you want to send to everyone in Harare, you use one address. You don't use all of their addresses. Let's say you have 1 million devices that you want to send information to. You don't have to know all the addresses of the 1 million devices. You just have to know one address. And that address is what we call the broadcast address. So what is the broadcast address? The broadcast address is all ones on the host portion. All ones on the host portion. So if we go back a little bit, we introduce the IP address, and we say the IP address is a number, 32 bits. The IP address is accompanied by the subnet mask. The subnet mask separates the network portion and the host portion. So once you know how to separate, this is the network side, this is the host side, then it becomes easier to know what is the broadcast. Because from what you've separated, you go and say, oh, one's on my host, then that becomes your broadcast address. More examples are coming. We'll probably get to understand a little bit more as we go. Unicast transmission is sending a packet to one destination, right? If I'm sending to one device, we call that unicast transmission. For example, here we have this PC trying to send information to this printer. So you can see information just go to the router and to the printer. Unicast transmission. If I'm sending to all devices on the network, it's called broadcast transmission. So this device wants to send to all these devices. That is all the devices in the network. It uses what we call a broadcast address via broadcast transmission. Very important. There is a difference between unicast and broadcast. We also have multicast there. In this example, multicast transmission is sending a packet to a multicast address group. Multicast is sending to 2 or more. If I want to send to one device, it's unicast. If I want to send, it depends on how many devices are in the network. Right, let's do it this way. In this network, I have 1, 2, 3, 4, 5 devices. If I want to send to one device in this network, this is me. If I want to send to one device, it's unicast transmission. If I want to send to 2 devices, it's multicast transmission. If they're in a group, multicast. If I want to send to 3, if I want to send to 1, 2, 3, and I leave this one, number 5 here, it's still a multicast because I'm sending to multiple devices. However, if I now want to send to 2, 3, and 4, it means I'm now sending to all devices in the network. Technically, it's no longer a multicast, it's now a broadcast. That definition will definitely change when you get to CCNA 2 or 3, but at this point, let's stick to that. If I want to send to all devices, broadcast. If I want to send to many, but not all, multicast. And if I want to send to one, That is what we call unicast transmission. Types of IPv4 addresses. Public addresses are globally routed between internet service providers, ISPs. Private addresses are common blocks used by organizations to assign internal hosts. Private are not unique. Private are not globally routable. Very important to understand what is a public address and what is a private address. Best way to explain this, let's have, this is our router, this is our network, this is our LAN A, and let's just have the internet. Let's have the internet there. Right here, we have what we call the internal network. That is my private network. That is our private network. Here we have the public network. The internet is public. Addresses that I have in my private network, I call them private addresses. Addresses that I use in the public are called public IP addresses. There are organizations which sat down and said there are addresses which should be private and there are addresses which should be public. And this set of addresses were said to be private. So this set of addresses are the addresses that you will see when you do our examples, when you do our configurations. The reason why is we are creating a private network at this level. We are not going outside our private network to the internet. Most of our configurations will be confined right here at this level. As you go to other levels, you get there. But at this level, our configurations are confined to the private networks. And that said, the addresses that you use, these are the addresses that you use. 10.0.0.0/8, 172.16.00/12, 192.168.00/16. If you don't see an address starting with those numbers, then it's public. Or any other type of address, but it's not private. That's why when we began, you probably saw a lot of 192.168.10.x. Private IP address. Public IP addresses, you probably see 209. I think in the example we did in module 10, there was an example with 209.165, let's say .10.1. That is a public IP address. What it means, it is an address for the internet. It's not a private IP address. Public IP address, they are globally routable. What it means is you can use a public IP address to communicate over the internet. A private IP address is not globally routable. So what do I mean? I can have an IP address privately. My IP address privately is 192.168.10.10. Over the internet, they don't know this address. It's not routable over the internet. The private address is not routable over the internet. As we go from 1 to 3 CCNAs, you see we have a function of the router which is called address translation, where this private IP address is changed to a public IP address. So inside here, I might call myself 192.168, but the router changes that address to a public IP address, so that it becomes globally routable. So over the internet, they might know me as Mr. Madondo, but at my house, they know me as Silence. Private IP address and public IP address. I think maybe not the best analog, but an okay analog. Everyone else knows me as Mr. Madondo where I work, but at home, they call me Silence. So Silence is private, Mr. Madondo is public. Guys at my work probably don't even know my name. They should not know my name. Difference between public and IP and private IP addresses. That said, as we go, you see that in this private network, LAN A, I can have this IP address 192.168.10. I can have another private LAN. Let me put it this way. Now I have two LANs, LAN A, LAN B. Okay, no, let's not have LAN B here. Let's have another router. Let's have LAN B here. So this is A, this is B. Private IP addresses are not unique. What do I mean? I can have a 192.168 here, 10.10 in this network. I can also have a 192.168.10.10 here. I can have a Silence at this workplace. I can have another Silence at that workplace. It's not unique in the network over all the networks, right? However, if we are on the internet, we cannot have two Mr. Madondos. It means this Silence is probably a Madondo over the internet, and this one is probably a Gaura over the internet. Both privately are Silences, but over the internet, one is Madondo, one is Gaura. So public IP addresses, they are unique over the internet. As we go, you see, since they are unique, it means we'll probably run out of addresses. The more devices we have over the public internet, the more addresses that we have, and at some point we'll run out of addresses because every device we have a unique IP address. Let's end this session right here. I can see I have 1 minute left. We continue after we end this one.